Yeah, there's 5.
I'm just going to take a picture of that. Is it in the textbook? It
Yeah, it's
is.
in 3. It's in section 3, or yeah, section 3.
Okay. All right.
All right, I'll read the next one. As cheese ages, various chemical processes take place that determine the taste of the final product. Concentrations of various chemicals were measured in 30 samples of mature cheddar cheese, and the subjective measures of taste was recorded for each sample. Higher values of taste indicate a more desirable product. The variable lactic gives the concentration of lactic acid in each sample. We want to know if there is a statistically significant linear relationship between the concentration of lactic acid in the cheese and the quality of the taste. We want to predict quality of taste given in concentrations of lactic acid. So check the requirements for simple linear regression with the variable lactic and taste. Complete the requirements are not all met.
Okay. Check the, okay, not all met. Create and attach the graphs. Okay, before I go ahead and go in and just do a QQ plot, do I need to do anything else? Do I need to do the linear thing?
Yeah, because it said before you have to do regression, linear, and then you have to check the box for unstandardized residuals.
Okay, what are we doing it between?
See, this is where I get mixed up. How do you choose?
Well, the dependent is the response variable. It's the main one. The independent, isn't the independent more of the one that is helping to predict it?
So if we want to predict the quality of taste given in concentration of lactic acid, which one do we pull over first?
I think taste. And then
lactic.
Mm-hmm. Okay, do I need to do anything over here?
Yes, go to save. And then on save you do, the unstandardized.
Okay, and then I do the graphs. Well, not graphs, but I go into...
Well, you just did the analyze one. Now you can do the graphs.
Oops. Now I'm just doing a QQ plot, right? And just bringing over the variables. Nothing else. All right, let's see if these look like them. No.
I think you need to do a scatter plot, not a QQ plot.
Yeah. Okay.
And that one's in graphs.
Whoops. That makes, okay. Oh, my brain's been somewhere else for a while. Okay, so taste, and then...
I think it goes to the unstandardized.
Do I do opposite? What's the X? Is X on the bottom?
I don't know.
Well, I'm looking at the homework as answer key. And lactic is on the bottom, and taste is
Let's try it and see what it looks like.
Lactic is the X, and
okay.
Well, they have two. They have one with lactic as the X and taste as the Y, and then lactic as the S and unstandardized residual as the Y.
Maybe we're supposed to do it 2 times.
Yeah, let's try. That doesn't look like it either. That's what I ran into with my... Oh, there. Does that look like it?
That does look like it. Go down again. No, it doesn't look like.
No, it doesn't.
Oh, it does. It does. Right there. That one does.
Oh yeah, that
This
one
totally
does.
does. It looks like the lactic and the taste. Okay, and then if I do the same thing and just, but okay, and pull over.
Instead of taste, put unstandardized.
Oh no, wait, that's supposed to be there.
Yeah.
That doesn't look right.
Let's see.
Let's
This
see.
one.
Oh, okay. No.
No?
Mm-mm.
No.
It might just still be loading at the bottom.
Okay.
Unstandardized.
I don't know what we're supposed to do.
Oh, that's the wrong thing. This is unstandardized predicted value.
Put the
Oh, this-
unstandardized residual. Did you save it? The last one?
No. Oh,
You're
I
supposed
haven't.
to save it.
What's that?
You're supposed to save the regression linear thing, and it should be saved as resolution 1 or res 1.
Residual.
Residual
What do
1.
I don't know how to save things. What am I supposed to do? Walk me through it.
You go back to analyze regression and linear.
Wait, analyze. Oh, the
Regression.
transform. Or the, no.
Regression.
Oh, I'm lost for a second.
Analyze. Go to analyze. And then regression is
Right here.
right there. Yeah. Linear.
Okay, but this is predicted value. Where do we get that residual? And do we have to make it?
Okay, you already have it. Yeah, you already have it. The way bottom one.
Did you
That's
check
correct.
off unstandardized predict? Go to the save button. Unstandardized. That's all you picked, right?
Put it on residuals though.
Put it on residual, not predicted.
Here? Oh,
Yeah, you were
Here?
there.
Yeah.
No, you were there.
back here?
Yes,
Yeah,
up
click
top. Right top.
Unstandardized on the left and click it on the one on the right. Click the one left out.
Am I supposed to do anything on here, you guys?
Yes.
Yeah,
Yes.
unstandardized under the residuals box.
Go to the right. There.
There you go. Click that one.
Now unclick the other
Take
one.
the other one out.
There.
And then you put OK. I think you just exited it out.
Yeah.
I did. I just wanted the, oh, I thought this would change.
You have to save it. So
Yeah,
go
you-
back to save
Oh.
and then unclick it again and then hit continue.
And then put OK.
And then do my graph.
Yeah.
Here's my thing. Okay. Thank you, guys.
Let's see if that works.
That looks just like it.
Yep. Awesome.
Super.
Would you put for the x-axis acidic or taste?
Lactic.
Lactic.
So how do you determine which one goes on X and which one goes on Y?
Let's read the question and find out. Let's see. You want to know if there's of lactic acid in the cheese and the quality of the taste. So they want to know taste with lactic acid.
So taste is the main thing, and that would be your Y.
Yeah. Or that's a good question. I don't know. Why is lactic acid?
Because it makes a huge difference in the numbers. Like, so we'll see. Let's go through and see if we did it right. after the plots.
Okay.
So create
let's
an
Okay, and then going on, let's see. Plots. This is in the answer key. The appropriate graphs to check for a linear relationship are a scatter plot and a residual plot. The scatter plot seems to show a linear relationship, and there is no pattern in the residual plot. So we can conclude that there is a linear relationship in the data. So create and attach is appropriate to check for the requirement of the constant variance based on the graph. What do you conclude? Okay, is this the same graph?
It is. Which
Um,
graph would you conclude? The appropriate graph to check for constant variance is the residual plot. There's
There's
no
no-
pattern, so we can conclude that there is a constant variance in the data.
okay. Oh wait, now I need to go into this again. Okay, now I need to save it with, there's instant, the expected normal value and the observed
you get
value.
Let's see.
Create and attach a graph that is appropriate to check for the requirement of a normal error term. Based on the graph, what do you conclude?
Is this on a QQ plot?
Yes.
Okay.
So should I do it through a normal QQ plot?
Yeah, I think so.
Yeah.
Because it says once residuals have been calculated in SPSS, we can assess their normally distributed using a QQ plot. Make a simple QQ plot of the residuals. If the point in the QQ plot are close to the line, then we conclude the residuals are normally distributed.
Okay, my only thing is just looking at the answer key, they're asking for an expected normal value and an observed normal value. I'm wondering if I'm supposed to create that or, you know, rename something. Back in this one,
Thanks for doing
find them. Okay, a couple of you were starting to talk.
In the homework, it says this. Not in the homework, but in the reading, it does the same thing. And it doesn't say to do anything different. Like, it tells us to do that one we just did with the unstandardized residual, and then it tells you to do the QQ plot, and it just says expected normal observed value. I don't know.
I was just going to see if there, it's already just here.
Oh, awesome.
Really?
Yeah.
So that's what I was like, well, maybe it's already here because it gave us a whole bunch of different options.
Didn't you do a QQ plot in the beginning?
Maybe.
Yes,
I think you did a QQ plot.
Okay.
Okay. Awesome. And it looks like that. No. Yeah.
And then it says the appropriate graph is to check for normal error is a QQ plot of the residuals. The points in the plot are close to the line, so we can conclude that there is a normal error term in the data. Compute the sample correlation coefficient. Okay, let's just go up and see. Do I need to do it this time? Yeah. Like I actually need to run that, right? Let's see. Or this. That's
It's
it.
R. Yeah.
Yep.
Is it 0.704?
Yeah, it's that. Okay. Good. Moving on. Someone else want to read 5? Just to spread it out.
Eddie wants to.
Go for it, Eddie.
Sure. Where are we at? 5?
Yeah.
Find the equation of the linear regression line used to predict the quality of taste of a cheese sample given its concentration of lactic acid.
Okay. So it's going to be y equals, is that negative 29.859?
Yeah, but how do we know that? That B?
Yeah,
Yeah.
the constant is the y-intercept, and the bottom one is the
X.
Okay.
The slope.
So it's going to be
Okay.
that plus 37.72x, I think.
Yes. 37.720.
Mm-hmm.
And then the Y, do we have on here that 49? Let's see. For 6.
Use software to predict the quality of taste of cheese sample that has a concentration of level 2.11 of lactic acid. Concentration levels?
Scroll down to the residual statistics.
So you just plug in 2.11 for x, don't you?
You plug in what?
2.11
Where?
for x.
Oh, because it gives you.
Oh. The concentration level Y equals.
Okay.
Yep.
Yeah, that's all you do.
So what did you do?
You plugged in 2.11 for x.
So you did that negative 29.859 plus 37.72 your times
2.11.
what?
Oh, just 2.11.
2.11. Okay.
And that's how you got that. Okay. 95 confidence interval.
Now do we have to use an applet?
Well, where do we find these numbers? Do I have to run a test now? What do you guys think?
This is the confidence interval. Isn't it already on the screen?
I don't think we clicked on that.
You didn't click on it?
No, I think I have to run something to get that confidence interval in there.
You do linear regression or analyze linear regression.
But yeah, I think we do have to click a box on the bottom or something.
Okay, I got to the part on the reading statistics. And then do confidence intervals.
Should I take off estimates?
No, you leave that on there.
Make sure it says 95 in the level, and then OK.
Here we go. Right here.
22.999 and 52.441. Sweet. Okay.
Okay. It's lactic acid.
State the correct null and alternative. It's just equals to and not equals to.
Equals 0 and does not equal 0.
And the test statistic is at 5.249, right under the coefficients. Yeah.
Okay.
The p-value is close to 0.
I guess it's 0.000.
And then we reject the null because the level of significance was 0.05.
Okay, they're going to have us do this 2 more times with 2 more data files on the homework.
I think we got it down already.
Let's do the the what's it called? The group meeting,
Okay.
unless someone. Are you okay, Donna?
Yep.
Let's see. I'm gonna stop sharing.
Oh, there it is.
Okay. I'm gonna open it up in SPSS so we can get into the
The group
files.
meeting quiz. Okay.
Yeah, for 23. $18 questions. Alright, we got 2 things going on. Another math self-efficacy and that.
True.
Are we on lesson 23? We are, right?
Yeah.
Okay.
So the answer to number 3 is C, right? It's just the hypothesis equation.
Yeah.
The B1 equals 0, but yeah, that's what we just talked about.
Right.
Okay, a residual is the difference between B and
Residual is an observation to define the difference between the observed value of y and the value that would have been predicted by the regression line.
So
Is that
C.
off?
Yeah, it's C.
awesome. Okay.
What was 3?
4.
What was 3?
Oh, that was also C.
Okay.
A plot of residual supports using linear regression when a plot of residual supports using linear regression when. Okay.
Isn't it? Well, it says when there is no pattern.
Yeah, no pattern. That's right.
Residuals are positive.
You see a pattern in the residuals.
Linear.
I know.
That's weird.
A plot of residual supports using linear regression
I'm
when.
gonna go with B. I think B is it.
You think B?
I think so. Yeah.
A plot of residual supports using linear regression.
I know A and D are not it because they're like scattered everywhere, so there's no pattern.
So what do you guys think?
Hold on. And it doesn't look like a megaphone either, but I think it's B.
Any other thoughts, you guys?
I'm just reading really quick.
Okay. Here. Let's get going. While she's looking that up, you guys, do you guys want to walk me through this?
Yeah. I will read it for you.
So I'm first just going in and doing this residual linear. Oh, well, you read it and then we'll figure out which one goes where.
Okay, so it says use the confidence interval as the explanatory variable and the score variable as a response variable.
Okay. So let's see. So the response, is the response the dependent? I forgot.
Yes.
Response is a dependent, yeah.
Okay, and then the confidence in the,
Yep.
okay. Should I just go ahead and scroll down, do you guys think there's any questions on confidence intervals?
Yeah, you should click that.
Just do it for now. Oh, whoops. And then, what do you think I should do right now?
Residuals.
Residuals.
Yeah.
Okay.
And continue.
Okay.
And then
What's
you
the
need to do a QQ plot too and a scatter plot.
Or just the scatter plot first, right? Or do you guys look at the questions that are below this?
The QQ plot is number 7.
Oh, do I need to do a scatter plot, you guys think?
I don't see one with a scatter plot.
Okay, I won't deal with it then. Whoops. All right, our variables now,
I would do that one. Confidence and unstandardized residual. I think. Okay.
see what happens.
The QQ plot, what can we say about these residuals?
Okay, so the residuals form a linear pattern, I think.
That's not an answer, though.
Yeah, it is, isn't it? Wrong.
On number 7 is the residuals are clearly not normal, the residuals are fairly normal, or the residuals look right skewed.
Did we do 6 already?
Oh, let me look. Sorry. Oh, I went up higher. Then I compute the residual. What's the Oh. Is that for the QQ plot? Compare there.
That's for residuals.
Yeah, whether the residual should be.
Because all I did was a QQ. I didn't do a scatter.
Do a scatter plot too.
Oh, yeah.
Let's see. No, wait. I go into graphs.
Do analyze residuals, don't you?
Yeah.
Yeah, you don't.
Oh, I guess you
Got it.
there we go.
Should I? Okay. Am I doing? Did confidence in the?
Y, I think.
Is that the saved one?
I don't know.
I think we switch them.
Switch them?
Yeah.
Like that?
And then okay.
Mm-hmm.
Okay. Do you guys know which one we're trying to look at?
At the very bottom one.
Yeah, go to the bottom one. That one.
Hence this arrow.
Wow.
So, non-linear.
It says when there is no pattern, that means there is constant variance, which means there is a linear relationship.
So C.
So B.
Yeah, B. I meant. Sorry.
Mm-hmm.
B for 6.
Yep.
All right. I'll pull this back up again.
And then this one goes to the QQ plot.
Which I already did, right?
Yeah, you already did that one. It looks fairly normal, right?
Mm-hmm. I'd say it's clearly normal, isn't it?
But this says clearly not normal.
Oh, yeah. Question 7.
Okay, and 8.
So we're doing the fairly normal, right?
Yeah.
Yeah. This one says, use software to create a scatter plot of the data. Give the scatter plot, residual plot, and QQ plot. Which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply. That one was, there's a linear relationship between X and Y. So that might be one because it's linear, right?
Is this the one you're talking about now, the unstandardized residual? Or do we want more of the... Do you guys know which plot we should be looking at?
It says,
All of them.
yeah.
It's all of them. It's the scatter plot, the QQ plot,
And there is
and the residual plot.
Okay.
the
So I
other
think
one.
there is a relationship, yes.
Then the next one is the error term is normally distributed. That's not even on here. The variance of error terms is constant for all values of x. The variance of error terms is constant for all values. I don't even know what that means.
They're totally different. I don't know how, like, they all... Well, I guess I'll need to look at the question, but...
There's only two that we want to look at.
Which, the residuals? These are the only two residuals, I think.
No, scroll down. That one's the one we want to look at. And your first QQ plot.
Okay, so this one's all over the place. And then, let's see, this one.
Okay. So,
They're completely different.
well, that's good, because if the scatter plot's all over the place, that means that it's linear.
Okay, so for 8, what are we doing? Residuals are normally distributed.
Well, it says check all that apply. So there's a linear relationship. So A, and I think the A, B, C, D, E is the observations are independent.
You guys mark them, and I'll just stay on. Do you guys want me to look at these anymore?
Let's see. The residuals are not normally distributed. The x values are measured without error. Is that one of them? Nope, that's not even one of them.
Oh.
Okay, I think it's just those two.
The first and the last one.
Yeah.
Okay. We'll try that. What is B1, the estimate for the slope? Round to 3 decimals.
Okay.
Okay, so for this,
You scroll up. It is 12.695.
this one, the slope, right?
Mm-hmm.
Yeah. All right, I'll just leave this here, and you guys put them in, and then I'll put the numbers in after we're done looking at it.
Now construct a 95% confidence interval, beta 1, input your answers, input your lower bound, and it's the lower, it's at the 10.674.
Is it the bottom?
Yeah, it's the bottom one.
Okay, so lower bound is 10.674.
Mm-hmm.
Upper bound is 14.715.
Perfect. What is the p-value?
Oh, the sig? Is that this up here, the 0.000?
Yep, it is.
Or right here?
Is that one of the questions?
The lower one.
The next one, it asks about the level of significance.
Oh, okay.
Sweet. Anything
Sweet.
else? Go on to the next question. Is there anything else that can be answered by this screen? A test value?
Did you do B for 12? What did you do for
We
12?
did C, right? Reject the null because the test
Oh, yes.
became
Is less than C.
alpha.
Yeah, I'd say it's C. All right.
Is there another question that can be answered here?
13.
13. If you reject the null, you have sufficient evidence to conclude that the slope regression line is not 0 or the slope regression line is 0. Which one did you do, B or D?
I'm going to look at the question again.
If you reject it and it's not 0.
Is not 0?
Mm.
All right.
If there's insufficient and there's not?
No, it's D. There is sufficient and it's not.
Okay.
Okay, now we need to do the crocodile one.
Um,
Did you get all the answers, Marjorie?
no.
We'll go through them.
Cuckoo, where's the crocodile?
S.
What does it start with? A G?
E. It starts with E. Asturian.
Crocodile modified.
All right. Regression linear. I'll just kind of go through the motions. Tell me what I'm supposed. Read the question. We'll find the response and the whatever the dependent.
Oh, you know what? This was on our homework, so let me look at it. So.
Head length is used for the body length. So I think
head versus the.
Head is the dependent, and body is the independent.
Head is the dependent?
Right?
I don't know.
I'm gonna go with that, yeah.
And we're doing residuals.
Is the dependent the x-axis?
Yes, it is.
Okay, then I think that's right.
And I'm just going to go ahead and like do everything. Do you guys want to scroll down and see if they ask us all the questions again? Like.
Yeah, we need a 95% confidence interval.
So.
And a margin of error.
Wait, should the head go to the X?
Yes.
Wait.
Yeah.
Yes. Because we it's like swapped, I remember.
I think you need to do the unstandardized one to the Y. Is that right?
I'm just going ahead and doing all the things right now. We can go back and look at it.
Yeah, you're right. Unstandardized would go for the Y.
Yeah.
So I need to swap that
Yeah.
for this one, I think. Okay.
Swap that.
So you think the head length needs to go for the Y?
No.
Unstandardized residual goes to the Y.
Yeah.
Oh. Because we're doing that. Okay, and what about, is this cool?
That's fine.
Yeah, that's good.
All right, let's start answering the questions then.
Awesome.
All right. Do we have a margin of error? That's upper bound minus lower bound divided by 2, right?
Yeah. So then we need to find the 95% confidence interval, which is right there.
What's the upper bound?
So we're doing this lower, the body length? We've been doing this bottom one.
Yeah, it's the bottom one, I think.
Okay, so upper bound is 0.135. Lower bound is 0.121.
So it's 0.007. That's the margin of error.
Yeah.
If we did it right.
What is it?
We'll find out.
0.007.
Okay.
So the lower bound is 0.121.
Yes. The upper bound is 0.135.
And our last question, based on your lower and upper bound from the last two problems, what can you say about beta 1? I'd say
this?
My brother is like that late.
Okay, Eddie's doing something.
let's do A.
Okay, and then, let's see. If someone else wants to submit it and the other person go back through and tell me the answers.
Okay. Submit it.
Okay, I'll give you answers, Marjorie. Let me get up to the top.
Go to 9.
Oh, okay, 9. Okay, so for 9, I have 12.695.
Oh shoot. We got
What
a
did
6.7.
what did we get?
66.
Totally doing this wrong.
Okay, so we got them all right until question 5 is wrong.
Oh, let's go back up to 5 and see. Oh, 5. All residuals up. Okay, that's the one that we were thinking. A plot of residual supports using linear regression when. Okay, let me see if I can look that up.
Okay.
What about look normally distributed? Catherine, look at which ones we got right and tell me those, and I'll at least plug those ones in.
Right.
Did we get 9 right?
We have 6 wrong. 7 is right, which is B. 8 is wrong. 9 is right. 12.695.
All right, and then give me 10.
It is 10.674.
674.
Uh-huh. 11 is 14.715.
Say the last 3 again. 14.
715.
7 what 5?
715.
Thank you. Sorry. I thought you said 0.5 or something.
Oh, no.
All right. 12. Did we get 12 right or wrong?
Did. That is C. 13 is D.
Okay, we got that right.
And then 18 is A.
Okay, we got all these other ones wrong. 18 we got right.
Yep.
Okay, so we just need on 14, we just need to put it to body length because there's only another possible answer.
Yeah.
Okay, do I need to go back into the test?
Yeah, you do.
Okay, so
I think we need to swap because it says a variable for dependent variable you need to put as body length.
Oh, sorry. Darn. Okay, this is okay. I'll just deny it right now. Thank you for running in here. Sorry, my daughter ran in here and slid on the floor. Okay. She is playing outside, but she has my phone, and they're playing in the sprinkler. I just noticed this. Okay, what do I need to do this? Can you guys please shut the front door? All right. I don't need to redo this.
The one on top, isn't it?
Yeah, we need to change it to body instead of head, I guess.
Well, it is body right now, isn't it?
Here, let me look at this. This is what we're talking about. Should we swap these?
Dependent should be body.
Okay. Well, let's swap this.
And let me check if you got that one wrong.
That's 14.
Is it?
Yeah, it says for the data, which variable is the dependent variable?
That is body.
So it's body.
Okay, so I'm
head length was used to predict body length. So we need to find body, like the body length is what we're trying to predict.
so like this, you guys.
Yeah.
Because if the body is what we're supposed to predict, then this is correct right
Yeah.
here.
Right.
Okay, everything else should be as is.
Okay.
So everything should change from there.
Yeah.
All right. So now it's 7.218 for the lower bound.
Yes, and 8.103.
7.218.
Okay.
And then we need to do the margin of error. 8.10. B1. Did we get 18 right?
Yeah, we did this one right.
Okay.
Okay,
Okay.
what's the next? What other? Do
So
I need?
we've got question 8 and question 6 and 5.
What did you get for the margin of error for 15?
Oh, can you guys tell me what the numbers are and I'll do it?
The upper.
Go
oh,
ahead.
Go ahead. Oh. Upper bound is 8.103.
Uh-huh.
Lower bound 7.218.
Okay. So the margin of error is 0.443.
Okay, 0.443. Okay. All right, so
Now let's get number
let's go back up to
5, 6, and 8 are wrong.
5.
Does
Okay,
that
the
have to
plot-
do with the other one, the math efficacy?
6 and 8 do.
What'd you get for number 18?
18 is A.
Okay.
A plot of
Okay.
residual support.
I don't think I have the output for the math efficacy. All right. So what did we? Let's see. Oh shoot.
So let's see. For 5,
Do I need to change the dependent on here?
so the plot residual support to linear regression when plot residuals when there is no pattern. That's all it says.
Okay, so right now we have the dependent. So think of, if you want, guys, read the question. Like, what's the response? What's the main thing we're trying to figure out? Are we trying to figure out the score here?
Oh, I'm looking
Or-
at 5.
Yeah, I'm looking at 5
Okay.
too.
I
So
think
it's
it might be C.
megaphone. Yeah, let's try. Because it can't be D because it says there's a pattern, and this says there's no pattern.
Yeah, and then it's not normally distributed. You know that. Yeah, let's try C on that one.
Okay, let's save that.
Now for 6, compute the residuals for the data using software statement describes it. So maybe it's A.
Well, are you pulling that one up, Marjorie?
I've got it prepped. If I was just
Okay.
wondering if we needed to change a dependent or something.
Compute the residual using what statement? Let's see, what is it asking?
It's asking describes the residuals.
Use
So-
confidence variable as exploratory variable. Oh,
So we just need the graph that we had before.
I think so.
Yeah.
Well, before I had the score in there. Is that fine? Or should I change it in for this unsubsidized?
Well, we want residuals as the X, or as the dependent, and then we want score as or confidence interval as the Y.
Okay. I'm wondering, I'm in this linear. Should I save it like this? Because before I had score in the dependent.
That's what
So-
it says. But we don't have a residual graph if we do that. So we want residuals as X and confidence as Y.
Do you guys want me to leave it like it is right now?
Yeah.
Like this. Okay. All right. And then we're just doing, are we doing a QQ or do you want me to do scatter?
Scatter.
Okay. We're fine here, right?
Yeah.
Okay. Now, do I need to do a QQ plot?
No.
Well, all the residuals are not negative.
and let's do negative 40 and 25.
Okay, let's try that.
And
Is
then
that all the ones that we had
wrong.
to fix? Do we have 7 right?
Yeah, we do.
And 8?
8 is wrong.
Okay, this is the one. Use this software to create a scatter plot of the data given the scatter plot, residual plot, and QQ plot. Which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply. Well, 1, 2, 3, 4. Maybe they have to be all checked because there are 5 requirements for a linear regression model. Let's see. The error term, that's not even on here. The variance of error term is constant for the value of x. Let's try.
That one is there.
That one is right. Yeah. So click on that one. Yeah.
And then
I don't think
next
that. No.
the x values measure without error. That's not even on there.
So leave C and D out.
Yes.
Wait, let's see. The variance of error terms is constant for all values of x. The x values are measured without error. Okay, let's try that.
X's are known constants. X's should be measured accurately and precisely. That's all it says.
Yeah. Okay, you want me to try and submit it this time? Are we missing any other ones?
Nope. The only wrong ones we had are, let me check again. We had 5, 6, and 8, and then 14, 15, 16, and 17.
Eddie, will you give me these following answers from 14, 15?
I haven't fixed
You
them.
haven't done it. Okay,
Okay, let me try.
Donna, you submit it. Catherine, you want to tell me them?
I don't have them either.
Okay.
That one, 14, is body length, though. Hold on.
You can go into your one submission. I guess don't worry about it yet.
88.89. What did we miss?
What are we getting that wrong?
Okay, let me go back through and I'll tell you which ones we got wrong. Okay. Number 5, again, is not the megaphone one. And number 8, again.
Just those two, though?
Let me go through. Yeah, 8 and 5.
Okay, so 5, what have we done? We've done megaphone and what else did we do? B?
I think. What did we do? Let me see. What number is that one again?
I think we did residuals and megaphone. Well, we have 2 more chances for Eddie and I, to submit it for our first time.
Right. Let's try. Hold on. I just want to see why we're missing that. Why is that?
Well, then let's go with the pattern, maybe.
We didn't see a pattern. That's the problem. Okay.
It has to be either the pattern or the look normally distributed, though.
How do we do?
Bad. We got 8 and 5 wrong still. So 5, we know it's not. We did the residuals all positive before, correct?
Yeah.
Okay, so it's either the normal or the pattern. Do we want to go with pattern more than normal?
No, I want to go with normal. Because there's no pattern. I didn't see a pattern.
I'd say normal.
Me too.
Normal?
Well, Eddie and I can still try it for our first
Yeah, I'm
attempt.
just going to wait to input stuff until.
Yeah. Okay, and then 8 still. So is it giving us any percentage correct on this 8, or is it just saying wrong?
It's just saying wrong.
I hate that.
Okay, so what if we click on normally distributed?
Yeah, I think so.
Okay. Which other one was wrong, Donna?
5 and 8. That's it.
Those 2.
Oh, those were the only 2 wrong?
Yeah.
Okay. Oh, I thought we got a lot more wrong.
I was being dramatic, maybe.
Okay. Like, shoot.
5 and 8. So someone submit those. I'm going to write down my answers at least.
Well, I can't submit until I fill in the rest of these.
Okay. Eddie, do you have all the answers?
I was out for a little bit. What? Can you tell me all of them again?
All right, so let's go over it then.
Let me restart mine so we can all get the answers at the same time.
What is the number 5? What did we say it was? Normally distributed? A?
That's what we're going for this time, right here.
Yeah.
Okay. 6, I have A. Okay, you want to go through it? I'll give you the answers I have if everyone wants to.
Hold it.
Yes.
Okay.
Yeah. Let's start with 3.
3, we have C.
Uh-huh.
4, we have C. 5, we have A. 6, we have A. 7, yeah. 7, we have B. And then 8, I don't know what we're going to do. Are we going to do A, B, D, and what was the other one?
I think we should just do A, B, C.
A, B,
Just
C?
do all of them.
You want to do all of them?
Yeah,
Yeah.
do all of them.
Okay, let's do all of them.
But don't click on yours, Catherine, until
I'm not.
Eddie and I try ours.
Yeah.
And then 9 is 12.695.
You can look on my screen, Eddie.
Uh-huh.
And then 10 is 10.674.
Hmm.
And then 11 is 14.715.
Hmm.
And then 12 is C.
Okay.
13 is D. 14 is body. 15 is 0.443. 16 is 7.218.
7.218.
Yeah. 17 is 8.103. And then 18 is A.
Okay, I'm turning them in.
All right.
Okay.
Got a 94%.
What did we get wrong? My
Number
gosh.
8.
8.
It's just 8. Let's see.
Is that the only one we got wrong, Eddie?
Yeah, just number 8.
So
All right.
number 5 was, okay, the normally distributed?
Yep.
Okay, so I
So-
can,
Let's unclick the last 2.
all right, Catherine, your turn.
I already
No,
won. Marjorie.
Marjorie.
I still have 1 turn, or 2 turns.
Yeah.
Okay, so I just unclicked these 2 right here, you guys.
And just
Yeah.
did ABC? Okay.
We'll go for it, and then all these other ones, hopefully I've entered in correctly. All right.
1.
You guys, we did it. All right. Let's see, Eddie, do you need to go through the answers again?
Yeah.
Okay. Can you just see my screen?
Yeah, just give me 1 second. while
I'll walk you through it. If you guys want to head out, I'll walk Eddie through this.
Okay.
Or whatever.
I gotta put mine in too.
Okay.
So